Hi students, welcome back. Now we are going to discuss some problems in inverse trigonometric function. Question number 1. Find the principal value of sin inverse 1 by 2. It is the value of an inverse trigonometric function which lies in the range of the principal branch is called the principal value of that inverse trigonometric function. Solution. Let can take y is equal to sin inverse of 1 by 2. First step y is equal to the answer and the principal value branch sin inverse x in the principal value in the branch in the parameter. It is its range minus pi by 2 to pi by 2. Sin inverse x angle if f of x is equal to sin inverse x, this y equal to sin inverse x, then x is an element of domain in the parameter minus 1 to 1 and the range that is y is an element of minus pi by 2 to pi by 2. This is the principal value branch. The principal value is principal value principal value branch point. That implies if y is equal to sin inverse 1 by 2, we can say that sin y equals 1 by 2. Inverse trigonometric function sin inverse x is not equal to sin x raised to minus 1. Sin x whole raised to minus 1 alla. Sin x whole raised to minus 1 it is 1 by sin x. Sin inverse sin x raised to 1 minus 1 is 1 by sin, that is cosec x. Sin inverse x sin x raised to minus 1 same alla. Y is equal to sin inverse x, we can write that implies what is x is equal to sin inverse it will become sin y. So sin y is equal to 1 by 2. Then we sin 30 degree, that is sin pi by 6 ആണ് 1 by 2. That implies we can find y is equal to pi by 6. Clearly it is an element of minus 90 to 90. Minus 90 90 pi by 6. So the principal value of sin inverse 1 by 2 is pi by 6. Clear? Next question, question number 2. Full at sin inverse 1 by 2 sin inverse of minus 1 by root 2. But in our principal value for that, let y equals sin inverse of minus 1 by 2. That implies we can write sin y equals minus 1 by root 2. That implies sin y equals minus sin pi by 4. Sin 45 and 1 by root 2 minus sin pi by 4. Minus sin pi by 4 minus sin theta, we can write minus sin theta എന്നുള്ളതിനെ നമുക്ക് sin of minus theta എന്ന് എഴുതാം. Minus tan theta ആണെങ്കിലും we can write tan of minus theta. Same way minus cosec theta, we can write cosec of minus theta. Next minus cos theta in the kandal we write cos pi minus theta minus cot theta, cos cot sec cot of pi minus theta. Next one is minus sec theta. Minus sec theta we write sec of pi minus theta. The interval 0 to pi ആണ് principal value branch. Minus pi by 2 to pi by 2. Negative angles are. That implies next sin y is equal to minus sin theta, we can write sin of minus theta, that is minus pi by 4. Here y is an element of y must be an element of closed interval minus pi by 2 to pi by 2 and range. That implies y is equal to minus pi by 4. Then the principal value in the principal value is minus pi by 4. Since this is an element of minus 90 90, then I got check it out. Okay. Next question number 3. Sine inverse of minus 1 by 2. Let y equals sine inverse of minus 1 by 2. Y is an element of closed interval minus pi by 2 to pi by 2. Next step is that implies sine y equals minus 1 by 2. That implies sine y equals minus sine 30, that is pi by 6. Minus sine theta, we can write minus sine theta equals, we can write sine of minus theta. Moon angles in another minus sine tan cosec, minus sine tan cosec. This is minus, we can write sine of minus theta, minus tan theta, we write tan of minus theta, cosec minus cos cot sec pi minus out. Okay. Minus sine theta, we can write sine of minus theta. That implies sine y equal to sine of minus pi by 6. That implies y equals minus pi by 6, which is an element of closed interval minus 90, 90. Okay. Therefore, principal value of sine inverse of minus 1 by 2 is minus pi by 6. Next question number 4. Let us discuss cos inverse minus 1 by 2. Let y is equal to cos inverse of minus 1 by 2, where y is an element of closed interval 0 pi. That implies we can write cos y equals minus 1 by 2. That implies cos y equal to cos minus 1 by 2. 1 by 2 that table are sine cos tan specific angles in the values. Just sine cos tan angles 30 degrees 0 0 30, that is pi by 6, 45 is pi by 4, 60 pi by 3, 90 is pi by 2. The values sine 0 is 0, sine 30 1 by 2, sine 45 is 1 by root 2, root 3 by 2 and 1, cos 1, root 3 by 2, 1 by root 2, reverse order 1 by 2 0, sine by cos is tan 0, 1 by root 3, 1 root 3 and 95. This is sine cos 1 by 2 cos 1 by 2 pi by 3 cos 1 by 2 cos pi by 3 minus cos minus cos 60 minus cos 60 is 1 by 2 minus minus cos theta cos cot sec minus cos of, we can write pi minus theta. Cos minus cos theta is cos of pi minus theta. The next step is cos y equal to cos of pi minus pi by 3. We get cos y equals cos 3 pi minus pi is 2 pi by 3. Then y is equal to, the answer is y equals 2 pi by 3. 2 times pi by 3 is 120, which is an element of 0 to pi. So, the principal value of cos inverse minus 1 by 2 is 2 pi by 3. Question number 5. Now let us discuss one more question in cos. Cos inverse minus 1 by root 2. Same procedure. Y equal to cos inverse minus 1 by root 2. So y is an element of closed interval 0 pi. That implies cos y equals minus 1 by root 2. The next step is cos y equals minus cos pi by 4, that is cos 45, minus cos theta, we can write cos 180 minus theta, that is pi minus pi by 4. We get cos y equals cos 3 pi by 4. That implies y equals 3 pi by 4, which is an element of closed interval 0 pi. Therefore, principal value of cos inverse minus 1 by root 2 is 3 pi by 4 is 3 pi by 4. Next question number 6. Now let's discuss one question of tan inverse x, that is tan inverse of, write the principal value of tan inverse of minus 1 by root 3. Let y is equal to tan inverse minus 1 by root 3. The next step is implies tan y equals minus 1 by root 3, tan y equals minus tan 30, that is tan pi by 6. Tan 30 is 1 by root 3 minus tan theta, you can write tan of minus theta. It is cos cot sec, then only we can write pi minus theta. Minus that implies, step implies y equals, we get minus pi by 6, which is an element of the domain and the value in the tan inverse x must be an element of open interval minus 90 range of tan inverse x. So the principal value on the answer. So the principal value of tan inverse minus 1 by root 3 is minus pi by 6. Question number 7. Let us discuss one question, cot inverse. Cot inverse minus 1 by root 3. The first step is y is equal to cot inverse minus 1 by root 3. Then y is an element of range of cot x. Cot inverse x is open interval 0 pi. That implies cot y equal to minus 1 by root 3. That implies cot y equal to cot theta is equal to 1 by root 3. Then tan theta is equal to root 3. Tan theta root 3 avunadu, theta is equal to 60 degree, that is pi by 3. Tan 60, tan pi by 3. Tan 60 is equal to root 3. Then we know that cot 60 in the another 1 by root 3. P 1 by root 3 we can write minus cot pi by 3. Cos cot sec, pi minus minus cot theta, we can write cot of pi minus pi by 3. That implies cot y equals cot, we get 2 pi by 3. The final answer is y equals 2 pi by 3, which is an element of open interval 0 pi. So the principal value is cot inverse minus 1 by root 3 is 2 pi by 3. Next question number 8. Cosec inverse of minus 2. Let y is equal to cosec inverse minus 2 and range is y is an element of closed interval minus 90 to 90 except 0. Then the second step is cosec y equals minus 2. Actually sine 30 degree, that is sine pi by 6 is 1 by 2. Then cosec pi by 6 is 2 by 1, which is equal to 2. Then we can write cosec y equals minus, in the place of 2 we write cosec of pi by 6. Cos cot sec minus pi minus out. Then even in the cosec y minus cosec theta, we can write cosec of minus theta. Then y equals, we get minus pi by 6, which is an element of its range. So the principal value is of cosec inverse minus 2 is minus pi by 6. Okay. Hope you all have understood the concept. Okay. Thank you.